2015, number 4. Great little solubility equilibrium problem. I should draw a couple water molecules at the end for fun. So here we go. This should be a quick one for us. It says you have the following questions about solubility. It gives us calcium hydroxide, the KSP value, and it says write the balanced chemical equation for the dissolution of calcium hydroxide in pure water. So here we go. Dissociation of calcium hydroxide is going to form calcium ions and 2 of those hydroxide ions. You got to make sure you balance the equation here. That's the only hiccup, I think, in this particular problem. Make sure when you dissolve them they have charges on them. That's a free point. Everybody needs to get that one. B is a little trickier. It says calculate the molar solubility of calcium hydroxide. It is tempting in this guy to use that KSP and use calcium hydroxide and solve for X. The problem with this is that we have a common ion problem here because there's already calcium ions that are present. So the way this looks, equilibrium expression, when we set this guy up, KSP is going to equal the calcium ions times the hydroxide ions. Don't forget to square it. That's our generic or general equilibrium expression. Good. When we look at this, without doing too much rice table and answer part A, that guy doesn't exist in the equilibrium expression because he's a solid. This guy, our initial amount of the calcium is not 0 here. Our initial amount of our calcium is based off of the fact that we're dissolving this in calcium nitrate. So it's 0.1 molar. Do them in molarities, these are concentrations. So 0.1 molar. The initial concentration of hydroxide is 0. We are gaining on this side because the 0 is on this side. Here we're gaining 2x. Here we are gaining x. The question is, can we neglect this X on calcium? And the answer is we can, because if we multiply the KSP by 100, it's still way smaller than that initial 0.1 molarity of the calcium ions. And so for our equilibrium, what we've got here is 0.1 molar for the calcium times the 2x for the hydroxide squared. That's all going to be equal to the KSP value that they gave us, the 1.3 times 10 to the negative 6th. And we're solving for x here. And when we solve for x, that's going to be how much of this dissolves when we're sitting in a 0.1 molar concentration of calcium. And so X here, the molar solubility, is going to be 0.0018 molar. I wrote, that's the solubility of calcium hydroxide. Hopefully there's no questions on that. That's a tough one because of the common ion there. You've got to recognize that common ion in order to get that part B correct. There are 2 points in that part B. 1 point's earned for the correct stoichiometry and setup, and then 1 point's for the answer. And so this is worth a point, having that stoich. Make sure that that's 2x. Make sure that expression is squared. Good, recognizing that common ion. And then part C, says in the box below, complete a particle representation diagram that includes 4 water molecules with proper orientation around the calcium ion. So there's our water molecules, our Mickey Mouse's, negative on the oxygen side, positive on the hydrogen side, and so that calcium ion is going to get surrounded in solution by water molecules. You need 4 of them there. Size-wise, doesn't really matter whether they're bigger or smaller than that calcium ion you're looking at. The important part is that the negative side of the waters is all facing the calcium ion. That's it. Short and sweet for 2015. If you got any questions, make sure you yell at me.